Yes, a very good morning to all. This is Dr. Manjunath Chennapagod from Anveshana Academy, Bangalore, India. Dear students, in the previous class we discussed about what is Carnot engine or Carnot cycle, what are the importance of Carnot cycle and what are the important process of Carnot cycle, how it works, then how to calculate the Carnot efficiency. Then we derived an equation for Carnot efficiency in the previous videos. And also we done number of numericals on Carnot cycle or Carnot engine. So dear students, today I will move towards next topic. That is Otto cycle. The next topic is Otto cycle. Nicholas August Otto, he is a German scientist. He invented the Otto cycle. So based upon that Otto cycle, we designed the petrol engine, and we are using that petrol engines in our day-to-day applications, dear students. So Otto cycle. Now I will move towards Otto cycle. So dear students, before moving to Otto cycle, so I would like to discuss about steam engine invention. Why steam engine invention? Before to Otto cycle, steam engines were used. Steam engines, okay. So before to Otto cycle, steam engines were using, but those steam engines having some drawbacks or demerits. Because to overcome those demerits or drawbacks, later stage the scientists, they have put sincere effort to search or identify an engine which is burning the fuel inside the cylinder, that is internal combustion engine. They have tried, they have done a lot of experiment to get a compact engine which burns the fuel inside the cylinder. So in this research, one of the scientists, that is Otto, has invented a compact engine later. But before to that, we are using steam engine. What is the steam engine? That we will study today now. So to understand the steam engine, dear students, I will tell you one small story behind the steam engine. Okay, one scientist in Europe, that is Scotsman James Watt, he was sitting beside his mother, and silent in the kitchen while cooking. Okay, thus James Watt was sitting beside his mother in kitchen while cooking, and silently and keenly is observing the movement of the lid actually now. So while cooking, she has taken one pot, they put a water and rice, something else you can take. When it is steam is converted, water is get heated, right? Then it comes converted into steam. Then that steam is generating and it is coming up now. Because of that steam, when the steam is going to hit the lid of the pot, right, that lid is started to move up. Then he was observing why that lid is moving. He itself is questioning why this lid is moving. To move the lid, there should be some energy. Without movement, we can't get without any kind of energy. If the lid is moving because of an energy, that means what he came to know, that steam itself having an energy. Because of that sufficient energy, the lid movement is happening. That lid is moving. Then later what he has done? Yes, we can get enormous energy from the steam. That steam energy we can use for the different applications. Like that, he has started his thinking and his invention. Then what he has done? He tried a lot. He done a lot of experiment to convert that steam into mechanical energy. Then what he has done? Later stage, he has produced the steam. Then he has started his research and he started to do a lot of experiment. Then he produced the steam. Then that steam he trying to utilize to do some kind of work actually. Then what he has done? He tried to convert that steam energy into mechanical energy. Then later stage he came to know that to convert that steam energy into mechanical energy, we required a machine. we required in a machine. That machine will help us to convert that steam engine into mechanical energy. Then what he has done, he invented an engine or a machine. This machine taking as a steam as a working fluid, then it produced the mechanical energy. Then that machine he called later as a steam engine. Okay, so that means what he has done, he taken the steam from the boiler, then that steam is passed on to the engine piston. Because of that steam exposure force over the piston is started to move. That means what, that piston is connected to crankshaft again, the wheel started to move. Once it started to move means the engines will start to move from one point to another point. That means what, the steam energy is converted into mechanical energy. So later that engine we'll call it, popularly we will call it as a steam engine now. So that is invented by a great scientist. That great scientist is Scotsman James Watt in the year 1736 to 1819. Okay, in the 17th century, he invented a steam engine. Okay, what is the main panda here now? He observed that steam itself having a sufficient energy, that is nothing but what, steam energy, that can be converted into another kind of energy, that is nothing but what, mechanical energy. With the help of that mechanical energy, we can develop any kind of application as per our requirement. Hence the steam engine is invented by Scotsman. Then what he has done, he converted the steam energy into mechanical work or mechanical energy. So this is what, steam engine invention. Okay, invention. This is a small story, but dear students, in practically later stages, it is started to face some issues or some demerits. That what are the demerits that we will study now. Okay, so now you can see here now, dear students, as I told, the great scientist James Watt or Scotsman James Watt is invented the steam engine. But that steam engine itself, you can see here now, this is a steam engine. He has invented that the engine is running with the help of steam as a working medium. Okay, fine. But how they got the steam? They used a boiler to get the steam. Then that steam they have passed on to the engine. That means what? They are doing combustion externally. That means combustion they are doing in the boiler. From that boiler, what they are doing, they are taking steam. Then that steam they are going to pass on to the engine. Hence, engine will start to convert that steam energy into mechanical energy. Hence, it helps us to move from one point to another. Fine, that's fine. But external combustion it is taking place. That means what, it required a separate boiler for the combustion. And that boiler is big and it required water, and water storage it required. After work done, that steam has to be condensed. That required condenser. Then once the condensation is done, again to pump that water to the boiler, it requires a pump. That means what, heavy components are required to run the steam engine. So these are some drawbacks. How they are drawbacks, you can see here now, dear students. It's inefficient because it's a bulky. Okay, the steam engine, because it consists of boiler, pump, condenser. Okay, so engine, okay, engine parts, everything, it becomes a bulky and insufficient power. And it's a bulky one thing, and whatever the power it is going to generate, it is not so much. Hence it is a insufficient power generation. This is one drawback. Then second one, then it is using steam, but the steam boiling to convert that steam, so water to steam, we need to supply heat. To get that heat, we need to find the fuel. So that seeking for alternative fuels play a very important role here now. So alternative fuels were not at all getting. For that purpose, what they started to think, compact and efficient power sources. It is not a compact and efficient power sources. Okay, fine. So now later on, what they have started to do, instead of burning fuel inside outside the cylinder, is it possible for us to burn the fuel inside the cylinder, and that power can we use it to convert mechanical energy? Like that they started, and they have worked, the engineers later. So then they came to know that yes, internal combustion engines is possible. There directly you can burn the fuel inside the cylinder, then that energy can be, heat energy can be converted into mechanical energy with the help of an engine, internal combustion engine. So in this concept, yes, they came to know that internal combustion engines are possible. In this direction, one of the great scientists, that is German scientist Nicholas Otto, what he has done, he developed in a cycle. He cycle, then that cycle is used to produce the compact engine or petrol engine or gasoline engine, where the fuel is burnt inside the cylinder. Like that, the Otto cycle emergence become into the research actually. Okay, so like that they have invented the Otto cycle now. So in the 1876, Nicholas invented the Otto cycle. That is a compact and it is a fuel is burnt inside the cylinder. One thing, later in the mid 19th century, industrial revolutions drives demand for efficient power. Later, after inventing the Otto cycle in the 1876, many scientists in the mid of 19th century, they've done lot of research work on the engine, Otto engine. Then they have made some modifications. Then it becomes an industrial revolution. Okay. After that, in modern era, Otto cycle started to power the cars and various applications now. So that I mean, in the modern era, we started to use Otto cycle for a different engineering applications, to different engineering application. This is how the Otto cycles came into the application, came into the reality, dear students. Okay, so before to this Otto engine, steam engine was there. That steam engine having some problem or drawbacks or demerits we can say when compared to Otto engine. So therefore we move towards Otto cycle or Otto engines now. What is the difference between Otto cycle and Otto engine, that we can see here, dear students? First one is Otto cycle, second one is steam engine. What is the working fluid for Otto cycle? Yes, it requires air fuel mixture. Fuel you can take petrol or gasoline engine. But here water as a working media. As I told, water act as a working media or a working fluid. One thing, but the combustion whatever it is taking place in Otto cycle is internal combustion. That means what? Inside the, assume that, dear students, this is what piston and cylinder arrangement you already seen. When we are going to supply fuel, right, that fuel is going to burn into the cylinder and it is going to produce the power. Okay, power, because of that power crank will start to move, hence we can get the mechanical energy. This is what combustion takes place inside the cylinder. But when it comes to steam engine, here this is the engine. To get the work done from this engine, what we are doing, we are taking steam from the boiler, we are taking steam from the boiler, then that steam you can take from that boiler, what we are getting steam, right, that steam we are going to pass on to the engine cylinder. But what actually happened here now, the combustion takes place externally, but here combustion takes place internally. Hence this is what external combustion engine, whereas steam engine is an external combustion engine, whereas Otto cycle or Otto engine is an internal combustion engine. Okay, so internal and external, fine. Cycles, when it comes to Otto cycles, right, it is going to have four processes or four cycles here now. One is intake, compression, power and exhaust. When we are going to supply initially we are going to suck the air and fuel mixture, then it will be compressed. Once it is compressed at high temperature, what we are going to do, we are going to give a spark. Because of that spark, what happens, power will be generated, that is expansion process. Once the power stroke or expansion is done, then later next after work done, exhaust gas is going to come out from the engine, that is what exhaust. It is what in internal combustion engine, that is Otto cycle. When it comes to steam engine, but what actually happened here now, boiling will take place in the boiler. Later that steam is going to expand onto the piston and cylinder arrangement. Then we are going to get the mechanical work. Once the mechanical work is done, that steam is going to convert it into liquid with the help of a condensation process. Then after converting that steam into water, we are going to pump that water to the boiler again with the help of a pumping device. This is what steam engine. Then power output, it is an intermittent and it is a continuous, one thing. And what are the application of these Otto cycles, that you can see, dear students, cars or motorcycles you can take. But application of steam engines are trains, ships and factories. Okay, the efficiency of the Otto cycles is more when compared to steam engine. Okay, then as I told, dear student, this play a very important role. Size and weight of the Otto cycle is very small and it is a lighter. The size is very compact or small and it is a lightweighted. But when it comes to steam engine, it is a big one or larger and it is in a heavier. The weight of the engine is too high. So because of these reasons, low power, large and heavier, okay, and it is having a boiler and condenser and pumping all the components, and combustion takes place at outside. These all are what? It's very difficult for us to maintain for an applications what we are using, like car or motorcycles you can take, but it's difficult to bring to carry all these things to get our mechanical work. So for that purpose, Otto what he has done, he's tried to invent a compact engine which works with a gasoline engine. That too, the combustion has to take place inside the cylinder. By keeping such things in mind, he started his research and he is invented and finally he is succeeded. And he has given a engine, that engine we can call it as Otto engine or Otto engine. That Otto engine is developed based upon the fundamentals of what? Otto cycles. Then what is that Otto cycles? That we can see here, dear students. Now, how it actually industrial revolution demands, how this Otto cycle is developed. You can see now, industrial, there was a requirement for an engine, that to compact engine is there is a requirement in that. But initially engine requirement was there in the previous days. In that, what actually in the 17th century, James Watt, what he has done, he has invented an engine, that is steam engine. But that steam engine, as we know, it is having a lot of drawbacks or demerits. So demerits. Then the industry started to explore more work on the internal energy instead of external combustion engine. They have put a more effort. They have started a more exploration on the internal combustion engine. Then in that, the Nicholas Otto found a best solution that yes, it is possible. We can do we can invent, we can develop an internal combustion engine. Then he done a lot of work on an engine, internal combustion engine, using gasoline as a working media. Then he came to know that some engine operations, he has developed some engine operation based upon his research. Once the engine is Otto cycle is perfect and invention is completed, then what happens, the industry started to use that Otto cycles in their transportation applications. Later stage, like that the Otto cycle exists into practical applications. So based upon industrial requirement, James Watt has given an engine, but it is having a lot of drawbacks. Hence, the scientists they move towards to find the internal combustion engine. In that direction, Nicholas Otto worked a lot, and he has invented an internal combustion engine by taking gasoline as a working medium. Then he developed the cycle. Then he understood some engine operations. Then he given in a cycle. Then that cycle is utilized for the practical applications in the transportation later stages. Okay, fine. Now, so like this Otto cycle came into reality, dear students. Now, gasoline engine or Otto engine or petrol engine or spark ignition engines now. Okay, now Otto cycle, as we told, operations. What are the operations of that Otto cycles that we will discuss here now? So invention and impact of the Otto cycle. So how this Otto cycle is invented? This there is a requirement of efficient power machine and compact one. That too, it should take combustion inside. Such requirement was there. At that time, whatever the engine we are using, right, steam engine, it is having a lot of drawbacks. To overcome that, what the scientists they have done, they invented a compact power sources. That is gasoline engine we can call, or Otto engine. That Otto engine design based upon the Otto cycle. So by keeping all these things, then what they have done, they developed a compact source, that is nothing but what they have developed, an internal combustion engine. So but instead of external combustion engine, because it is having a lot of drawbacks, so they have not went for the external combustion engine. they move towards internal combustion engine. When it comes to internal combustion engine, it is going to have some operations. What are the operations he has understood? That Otto, Nicholas Otto, what operations he has understood? That is intake, first one, because air and fuel mixture is getting enter into the cylinder, that is intake. Later stage, that air fuel mixture is going to compress, that is we can call it as a compression process. Once it is compressed, then a small spark is going to give to that air fuel mixture which is already compressed. Then what happens? Sudden expansion will take place. That expansion we can call it as a power stroke or power process. Later, once the work is done, whatever the gas is burned, that become hot gases inside the cylinder, that will come out through an exhaust process. That is a exhaust process. It's a fourth one. Like that, four processes, four operations he came to know that during the investigation. Later stage, what he has done, later what we have concluded, we invented modern internal combustion engine, and we done some future advancement on the Otto engines. In the Otto engines or Otto cycles, to improve the performance of the engine and to reduce the emissions and to save the fuel, we done a lot of modifications in the internal combustion engine, and we done some future advancements in the Otto engines. But the base is the engine base given by Otto cycle. This is about Otto cycle, how the Otto cycle came into the picture, dear today, came into reality nowadays. So, dear students, we understood like that James Watt Otto cycles in the year 18th and 17th century. They have struggled a lot. They have done a lot of experiment. They have sacrificed their life towards the development of science and technology. They have invented a lot of things and they have contributed a lot. Because of Otto, because of steam, because of Otto, because of James Watt, we are comfortable now. We are using car, bike for our day-to-day application. If there were no Otto cycle, if there were no Nicholas Otto, if he is not invented the compact engine, if the steam, the James Watt, if he not investigated the steam engine, it is very difficult for us to lead our life now, because we are comfortable with car, bike, everything. So that is the what contribution of the Otto cycle. For that, we should be very grateful to the such kind of scientists who they have sacrificed their life towards the development of science and technology. This is about Otto cycle introduction. Okay. Thank you, dear students. Here I request you, please do subscribe my channel, like, comment, and do say. Your support is highly required for me. Thank you.